Hi, my name is Aditya Yadav. I am the CEO of Automaski, and today I am going to be demonstrating seismic inversion to you. I am going to explain what is inversion. It is applicable in oil and gas exploration, geophysics, mining, etc., even for moon and Mars exploration. So, the future of subsurface imaging, energy discovery, and Earth intelligence. Automatsky is a pure play full stack quantum computing vendor. It makes quantum annealers and gate based quantum computers. Its annealers can go up to 500 million qubits or Boolean variables, and it can solve sparse 100 million qubit problems in a matter of seconds. And its gate based quantum computers support hundreds of logical qubits and millions of gates. Automatsky is not dependent on any other company for quantum computing technology, and it also tries to help its customers and works on applications like optimization, vehicle routing problem, drug discovery, quantum chemistry and materials, quantum finance, CFD, quantum AI, cryptography, and nuclear fusion. And recently, we have entered into telecom and oil and gas. And next, we'll enter into energy use cases. Now, what is seismic inversion? Seismic inversion is the process of converting seismic reflection data into a quantitative model of the Earth's surface. What this means is you can take seismic reflection data and you can calculate the rock properties, geological structures, porosity, density, elastic properties, and fluid saturation. That is useful for geophysics, exploration, oil and gas, mining, moon exploration, Mars exploration, etc. Now, how does it work? So, when you need to acquire seismic data, you generate seismic waves and the reflections are recorded by sensors. Now, the physics models simulate wave propagation and algorithms adjust the Earth models and minimize the difference between observed and simulated data. So finally, what you get is uh, aligned or a kind of accurate Earth model that gives you velocity, impedance, reservoir properties, and geological interpretation of what's underneath you. Why does it matter? Seismic inversion is critical for oil and gas, for reservoir characterization, drilling optimization, hydrocarbon discovery. It is important for carbon capture and storage, CO2 monitoring, storage integrity validation, etc. It is important for geothermal energy, heat reservoir identification, basically exploiting the Earth's heat for energy. It is important for mining, where you try to detect ore bodies. It is important for earthquake science so that you can image the crust and map the faults. It is important for defense and security to figure out the underground structures. Now, main types of seismic inversion are post-stack inversion, pre-stack AVO inversion, full waveform inversion, and Bayesian geostatistical inversion. Out of this, full waveform inversion is the ultimate goal of seismic inversion. It is the most powerful. Now, seismic inversion is quite hard because the data volumes are massive, petabytes of seismic data. The physics is complex, non-linear wave equations, partial differential equations, multi-scale interactions, and millions and billions of variables, huge probabilistic search spaces. And as of today, full waveform inversion requires supercomputers, GPU clusters, and months of runtime. Classical systems struggle with partial differential equation solving, matrix sizes, they get stuck in local minima. And the Monte Carlo methods scale very poorly with number of samples, and the energy consumption is huge. Now, quantum computing can transform seismic imaging. We can use quantum annealing for sparse inversion, global optimization, phases estimation. Today I'm going to show you sparse inversion. Now this is not full wave inversion that I will demonstrate to you today. It is sparse inversion, but it gives you exponential advantage. You can use QAOA, you can use linear equation solvers, you can use quantum partial differential equation solvers, you can use quantum Monte Carlo, and you can use amplitude estimation to make breakthroughs in computing seismic imaging. Full waveform inversion is considered the holy grail of seismic imaging because it can produce extremely high resolution Earth models, reservoir scale details, highly accurate subsurface characterization. But the problem is that full wave form inversion is computationally explosive. It requires exponential computations, and the runtime is dominated by wave equation solvers, gradient computations, and iterative optimization. Now, the opportunity with quantum is that quantum computers can solve partial differential equations, linear algebra, and annealers can optimize problems in the matter of seconds. The Automatsky annealer takes a couple of seconds to optimize problems with 100 million sparse variables. Now, the advantages of using quantum for seismic imaging is faster imaging, better reservoir discovery. It increases the accuracy, uh, reduce exploration risk, lower energy consumption, and real-time Earth modeling because quantum computers can respond in a matter of seconds and minutes. The industries that will be transformed by quantum seismic inversion are oil and gas, carbon capture and storage, geothermal energy, mining, civil engineering, defense, and climate science. The market opportunity is huge. It is estimated that the global seismic services market is estimated at 15 to 25 billion dollars annually. The full waveform inversion market is growing rapidly due to offshore exploration, carbon capture, geothermal, and advanced imaging demand. The quantum computing market itself is expected to exceed $100 billion in the long run. And the opportunity of quantum seismic inversion could become a multi-billion-dollar vertical by itself, and it could be a core HPC and supercomputing replacement market opportunity. Why energy companies need quantum seismic inversion? The exploration costs are huge. Single offshore wells can cost $50 million to $150 million. Better imaging can save enormous capital in wasted well digging. Small improvements matter. Even 1-2% improvement in reservoir accuracy can create billions in value, and it will reduce the time from acquisition to drilling. Early discovery of hydrocarbons and geothermal resources and mineral deposits will be a competitive advantage. Quantum seismic inversion can become critical for strategic importance, uh, are critical for strategic needs. Now, it gives you energy security, it helps with national security, it helps transition the climate changes, it helps with rare earth mineral discovery, it is also critical for electric vehicles, batteries, and semiconductors. How could it change the world? It it would deliver more efficient energy discovery. It will reduce wasted drilling. It will accelerate geothermal energy and help us unlock geothermal resources globally. It will improve carbon storage safety, better natural resource management, faster scientific discovery, improving the understanding of the Earth's structure. It will also help with planetary exploration outside Earth, and future applications could extend to Moon, Mars, and planetary subsurface imaging. The top energy companies exploring quantum with for energy use cases are Shell, ExxonMobil, BP, and Total Energies. Now, let me quickly take you to the demonstration. Like I told you, this is not full waveform inversion. This is sparse inversion, but it is delivering exponential advantage. You can see that the number of samples is entered here. I have just kept it small for the demo, but given a certain number of qubits, you can handle an exponential number of samples, which is how it delivers exponential computational advantage. Now, I'm loading the seismic data and I'm running the inversion process. It should take around 30-40 seconds. I forgot to tell you that it is using both the Automatsky's quantum annealers and Automatsky's quantum computers in this use case. Seismic inversion requires the use of both gate-based quantum computing and quantum annealers. So both are being used right now. The problem is being formulated. There you go. So this is the seismic inversion, reflectivity to colored impedance chart, low frequency impedance, quantum colored impedance, forward synthetic from inversion, porosity proxy, annealers pass reflectivity. So you can look at the logs of the annealers, the Kuber terms, the expectations of the formulation, etc. Now, like I told you, this is a small demo. It delivers exponential advantage. Then the next question you will ask me is why didn't we develop full waveform seismic inversion? Why did we do sparse inversion? Because sparse inversion took us less than 1.5 months to develop and test, while full waveform inversion is a 1.5 year project in itself that would cost more than $5 to $10 million in development and testing. So that's all we had to show you today. If you have any questions or you want to reach us, please email info@automatsky.com. Let us know how we can help you. Thank you very much.